Okay, so we have a problem which says on a hot day, the temperature of an 80,000 liter swimming pool increases by 1.50 degrees Celsius. What is the net heat transfer during this heating? Ignore anything such as loss of water by evaporation. So let's start by writing down what we know. Delta T will be our change in temperature, which we know to be 1.50 degrees Celsius. And we know the volume of the pool is 80,000 liters. Now, the main equation we're going to use for heat, or specific heat, is Q is equal to mc delta T, where Q is your heat transfer, M is your mass, C is specific heat, and delta T is your change in temperature. So we know delta T. C we have to look up, and this is all. Q is what we ultimately want. We can usually they give you some sort of chart for this. I have C for us, and we know this. Mass we have to be a little tricky about, because we know density is equal to mass divided by volume, or mass is density times volume. So I can substitute this in here. And now our equation becomes Q is equal to dVc delta T. Okay. So the density of water is, I looked it up, about 997 kilograms per meter cube. Our volume is 80,000 liters. But to get that into a unit that's a little bit nicer, let's use the fact that 1 meter cubed is equal to 1,000 liters. And there you can see the meters cubed will cancel with the meters cubed, the liters with the liters, and we're back to our unit of mass that we want. So the specific heat is 4,186. That's the specific heat of water. And I want to say that has units of joules per kilogram times Celsius, I think is what that is. And then the change in temperature. What's the change in temperature was given to us. You can see the Celsius drops, the kilogram drops, and we get a unit of joules, which is what we want, because that's energy. Let's see. So it looks like we should get about 5.01 times 10 to the 8 joules. So over this hot day where the swimming pool changes its temperature by 1.50 degrees Celsius, this large pool sees this much heat transferred, which is I don't know, it seems like a decent amount to me, but I don't really work with pools much. But yeah, the big thing to know here is obviously your main equation, Q equals mc delta T. That's a big one to just memorize. I'll even box it. And then know that density is mass over volume, so we can substitute. And then it's just making sure our units are right. So not too bad of a problem, and hopefully that helps out.